Hi, everybody. I have to admit I'm quite honored to have been selected for a quarter talk, and I would have been into trouble if not with my Android slide. Yeah, because Android slide, we are in France, so it's mandatory to have a gastronomic menu. I finished my slide one day ago, just yesterday, and I ultimately learned some stuff while doing this presentation, still learning, so maybe I won't even respect this menu. Indeed, I won't say unnecessarily call me an expert in data science, or my company is named Data Science. Because I had the honor to attend the first user presentation years ago in Vienna. At those time, I was just a statistician. Then I was data miner, and now I'm data scientist. Company is called We Love Data Science, not because it is very sexy, but it reflects the fact that the job has changed a lot. So how to create a model? No, if you are here, you will know. You launch, let's say, RStudio, why not? You load data, so it's only technical slide, all the rest will be commercial. Then you upload your data to the cloud, choose which one, Amazon, Azure, as you want, you name it. You invoke your magic function that does everything for you with auto machine learning, and that's it, you deploy. Okay? That's the end of my presentation. I hope you are happy. You are happy. Also, everyone do agree? No, I want to have control. So for me, that's totally wrong. Maybe that's the future. Okay, so I don't say in 2 years, 3 years, maybe we will do that. It will be our job. But up to now, for me, machine learning is far more than that. So here is our gastronomic menu. All those steps are part of the job, and it's nice to have the occasion to do everything like that. It's a full process. It's a full process. So that's the reason we need framework, so-called framework. We need consistency indeed. If you want to fit a linear model, you just have call LM with a formula. If you fit, I don't know this methodology, but okay, I picked this one. This method, adaptive mixture discriminant analysis, nice one. You will give a data set and then classes labels. And in case of binary discriminant analysis with the bin package, it will be a factor that you have to pass. So there is no consistency, and we have so many modeling functions in R and so many packages. You will even find similar troubles when you want to predict, when you want to retrieve variable importance, when you want to retrieve a metric, accuracy metrics. So that's really fuzzy, all this ecosystem. And okay, I'm lazy, so I went to Wikipedia to say what is a framework. And I just truncated the sentence because I found that funny. So that's not necessarily about what I mean by framework, which is my meaning by framework. I mean a set of limited verbs that allows you to act as a wrapper around all those ecosystem of packages. Something you can play with, something you can extend eventually to obey your needs. And the fact that you have only one package to learn to do everything, and that's nice. Okay, I did retain some package. Okay, there are others. So I just check on CRAN, all packages and machine learning, data mining and stuff like that. So I found also those ones. If you have time, you can check. My presentation is online, so you will be able to check from yourself. So I have this gastronomic menu. I will review some functionality, typical functionality of task of a data scientist. And there is a game. Try to ask yourself, how would I handle that if I didn't have a framework? If you are here, I imagine most of you already know Caret, for instance, but without Caret, let's say, how would you do? So pre-processing, very important. That's the main reason maybe I don't currently believe in only AutoML in cloud, but I say we have still some room for data scientists and creativity. Pre-processing is about dealing with missing values, pre-treating predictors to center and scales, treat outliers, though you have some smart techniques that allow you not caring about outliers at all. But you know, all the stuff, there are some tests to say, I will prepare my data so that my data are tidy, clean, whatever, to enter into all those modeling techniques methods. Feature selection is another step. So feature selection, you have two types of feature selection. One that is before modeling. That is, you will, for instance, delete some very correlated variable. You will, with target, you will keep only one variable within a set of correlated variable. You will filter near zero variance variable. You will select variable with high relation to target, something like that. And there is also feature selection while you are learning, within your learning. Okay, so that's different stuff. Please remind that. There is feature extraction, multi-dimensional reduction, stuff like that. So a lot of steps. Okay, you are here. So I did skip my 100 slide, and let's say enter into detail about framework, but that's so that you see the importance of having a framework that handles everything for you for this kind of task. Sorry. Yeah, better. So I hope so far you are convinced and you are here to learn about that. There are frameworks that are nice to use. Okay, so I introduced one of the first contributors to this kind of framework, Max Kuhn. I don't know if he's here, but kudos to him. Pretty nice work. Author of Caret, now currently working for RStudio. So RStudio is launching its own, let's say, tidyverse for modeling. Also managed by Max Kuhn, with other packages like recipes and embed. And then there is another framework called LMLR, and then there are two frameworks based upon superlearner theoretical framework. Some package I have written do about data preparation, the other merely about modeling, and what I find great is also, because I'm fan of that, ensemble stacking. So we should cover most of the steps for to address the predictive modeling problem. The idea of my talk is that I will try to show you some stuff just so that you know that exists. So it's not learning stuff, it's just so that you know you are create some awareness. Okay, those framework, basically you just say, okay, let's start from those data. So I hope everyone knows those data. Just with using framework Caret, I can have an idea of those data. So I think it's a typical and good data iris to assess predictive modeling classification models. So Caret stands for Classification and Regression Training, acronym. And you have a core functionality that is a train function. So mostly one function to learn, train function. A train function has several arguments. Obviously, you will have to pass a model. Caret is a wrapper around 300 different families of models in various packages. It will manage for you the hyperparameter optimization using a grid search. It will manage for you resampling parameter and especially cross-validation. You have some functionalities for pre-processing variable, dealing with missing value, imputation, centering, scaling, and you can choose which metric you want to optimize, though I'm not sure you can define a custom metric, but what way. And then you have some other functionalities, such as creating data partition to split between train and valid/test data set, and that's it. And then you can work with your object also, the result of train, to extract variable importance and to extract also additional metrics. Okay, let's see a little bit. So first instruction, what I do with my model, I split my data set with regard to my target species. I want to classify with species with a given proportion for training set. Okay, so I build my training and my testing set. So very difficult so far. I will define some parameter I will pass to train function, like the train control. That's the place I will say I want to do a cross-validation. Okay, so five number, and I define my metric I want to optimize also. So several metrics possible. And then it's just calling the same function 3 times. And if you look at those 3 examples, I'm building 3 models, exactly the same call. I'm just changing the method. That's all. So far simple. Good idea to regularly set the similar seed if you want really to compare the model. That would be a good idea to set the same seed every time. This is an output of Caret. What we can see is what has been done and already some accuracies. Behind the scene, you can see that Caret has for you already built a grid, a small grid on hyperparameter. So the C parameter of super vector machine has been tested for various values. You can customize that, and you can even pass your own grid. With Caret, we can preprocess, so preprocess function, and then you have package Caret ensemble that will be used to stack model. I will go quickly on the slide. Once again, presentation is online, just so that you are aware that does exist. So stacking is possible. You can manage a list of models. Here are 2 models. And then I take ensemble, and then I stack those 2 models with a meta model. MLR framework is oriented, its concept is articulated around concept, and you have objects corresponding to learners, resampling, tuning, parameters. Every conceptual functional is an object. You have a pre-processing extension package. It covers a lot of topics. Parallelization is there, and hyperparameter is done with more possibilities like simulated annealing. You have then a new rebranding version of MLR3, so it will be talked after. Nice stuff, articulated around data table, R6 classes, and future package for parallel computation. And then there will be a talk also on pipelines. I want to talk about recipes also. Recipes is from RStudio and in tidy model, and it's very complete to preprocess your data. Plus, it has an integration with Caret. That means that you can integrate recipes within Caret. So you will find example if you want. Many ingredients, more complete than the start function in Caret. And you can have the embed package for optimized supervised categorical predictor. It's very small, so I won't say everything. Just to say that there was some point. I put some point. As I'm coming from Belgium, we like consensus, so we have 2 same points for Caret and MLR. My opinion is that to begin to enter the world, Caret is nice, because Caret has a lot of Stack Overflow and questions. But if you want to go deeper into machine learning, if you want more functionalities, if you want to be more correct in terms of methodology respecting, I would advise to go on MLR. Okay, so that's my comparison. When I finished my slide yesterday, I had a GitHub activity of 5 hours for the last commit on MLR. So I was impressed. Okay, so just a note, because in my abstract there was something about tidy modeling. 2 or 3 years ago, tidy modeling was referred to the fact that more statistical models, for instance, to group by modeling with regard to country or subpopulation. So it's not what we refer now as tidy modeling for machine learning. It's not exactly the same stuff. I really need a wrapper MLR for recipes, so please, people from MLR, it will be difficult because data table is not compatible with recipe, I think, but that would be so great to have a manipulation with recipe equivalent and all those recipes for MLR3. All those words, both RStudio, tidy models, and MLR, they have a really nice community. They are very reactive, so if you have questions, then you don't hesitate and you will be very welcome. I had some questions on it. It was answered directly. That's very nice. If you try to use external packages such as H2O or CatBoost, you may sometimes encounter some issue with those packages because, for instance, CatBoost has its own way to store internal models, and I ended up sometimes with incompatibilities. But okay, that's life. So maybe those frameworks do not cover everything, but still, okay, it's a nice place to begin with. That's it. So you will find my slide here, and I will. This is marked down, so I will convert it into PDF so that everyone can access it also.
Today there are about 100 new packages per month on CRAN, and some of them deal with new methods, new algorithms. Is there any way to integrate them in Caret, MLR, or?
Yeah, those are both Caret and MLR are framework, and that means that's extensible. If you find a new method and you find it nice and it's not already covered, you can easily write your own additional function, respecting the same template as those packages propose, and it will be available then. Yeah, totally, definitively.
And which package among Caret and MLR, which one would you recommend to, if you would do extensive?
Both allow that, huh?
Both? Okay.
Yeah.
Anybody else?
Hi, thank you. Have you done some benchmarking to test whether the MLR and Caret produce the same results on the same parameters?
So I didn't perform benchmark. I played with those packages for various customers on project.
I mean, they should produce the same result, right?
Sorry?
They should, I mean, assuming same parameters, same type of analysis, they should be exactly the same, no?
When the function behind is the same, assuming the same random seed, maybe, why not? Yes, but it's just yeah. But I think MLR has its own implementation from some learning stuff, so maybe not exactly, but okay. But I didn't do benchmark neither for performance, and I didn't try parallelization of computation. But that's a nice feature also. Huh? That's only adding one option, and you benefit of a cluster. So. For random forest.
Time for one more question. Gentleman over here. Yes.
The formula interface that some of these frameworks use is well known to waste memory because it makes several copies of the data frames in memories. So are there workarounds for that?
Yeah, you're definitely right. It has an overhead. Both packages allow to pass without the formula approach. I mean, you can specify X and Y. So sometimes I try to manually, programmatically expand the set of predictors and pass the other way with the other syntax.